In this video, you will learn how to convert quadratic functions and equations into their intercept form. The intercept form is also called the factored form, and it is in the form y equals a times x minus p times x minus q. So let's recall the standard form of equation. The standard form is y equals ax squared plus bx plus c. A here is the same value as the a in the standard form, and p and q are the x-intercepts. So how do we solve for the x-intercepts? We just have to set y equals 0 to solve for x-intercepts. Now let's try solving some practice problems. So let's say we're given f of x equals 4x squared plus 10x plus 4. Now to write this equation in its intercept form, we need the x-intercepts. So we factor 4x squared plus 10x plus 4. Now to factor this, we can extract or factor out 4 here, or 2, because 10 is not divisible by 4, but it is divisible by 2. So we factor out 2, then we are left with 2x squared plus 5x plus 2. And now we can factor this equation here, 2x squared plus 5x plus 2. We can either use the AC method or the shortcut trial and error. So let's do the AC method. Right. So let's copy 2 here, and then we will factor 2x squared plus 5x plus 2 using the AC method. So this is what we're going to do. We multiply a and c, so that is 2 and times 2 is 4. Then we remove 2 from the leading coefficient or the leading term. So that would become x squared plus 5x plus 4. And now we've already got rid of the leading coefficient here. We can factor this further, this expression x squared plus 5x plus 4. Copy 2 here. So we factor this. We look for factors of 4 that when we multiply them, it would equal to positive 4. And when we add them up, it would equal to positive 5. So the factors of 4 are 2 and 2. 4 and 1. So 4 and 1 here are the only factors that would add up to positive 5. So we will use plus 1 and plus 4. Right, and now we replace the leading coefficient by the original coefficient, leading coefficient, which is 2 here. So that would be 2x plus 1 times 2x plus 4. And then we factor further. So this would be 2 times 2x plus 1 times 2 times x plus 2. And then we divide this. We divide this by the original leading coefficient, which is 2. This one. Okay, then we cancel out 2 here. Then we are left with, let me use red. Okay, f of x equals 2 times 2x plus 1 times x plus 2. And now we've already factored this equation. And the factors are 2 times 2x plus 1 times x plus 2. You can always do the FOIL to check the equation if it's, or the factors, if they are equivalent to the original equation. Okay, we have f of x equals 2 times 2x plus 1 times x plus 2. Now we can solve for the x-intercepts. So we just have to equate each one to 0. So we can just cancel this constant when we equate this to 0. So this will be 2x plus 1 equals 0. Therefore x here is negative 1/2. And the other x-intercept is equal to negative 2. Therefore, the x-intercepts of this quadratic equation here is are negative 1/2 and negative 2. Now we can write our equation in its intercept form, and that would be a, that is a times x minus p times x minus q. So a here is 4, then x minus p. P and q are interchangeable, so you can either use negative 1/2 or negative 2 first. So we use negative 1. X minus negative 1/2 is x plus 1/2 times x plus 2. So this is the equation in the in its intercept form. Now let's solve another problem. Alright, let's solve another problem here. So let's say we're given f of x equals x squared minus 9, and x squared minus 9 here is the difference of two squares because 9 is a square. So we can just write this equation as x plus 3 times x minus 3, and then we equate each of the factors to 0. Therefore the x-intercepts here are negative 3 and the other one is positive 3. And now we can write this equation, quadratic equation, into its vertex form. So a here is equal to 1. So 1, then x plus 3 times x minus 3. So this is now the factored form or the intercept form of this equation. Let's try another problem. Okay, what if we're given f of x equals x squared minus 6x minus 7? Now we can factor x squared minus 6x minus 7. Okay, we look for factors of 7 that when we multiply them, it would equal to negative 7. And then when we add them up, it would equal to negative 6. Since the middle term is negative, so that means the larger number should be negative. So we can use negative 7 and 1. Because negative 7 times 1 is negative 7, and negative 7 plus 1 is negative 6. We can use negative 7 plus 1. Or you can still use the AC method, the one I previously used in the first problem. And to check this, you can do the FOIL. So these are now the factors for this equation. Then we can equate each factor to 0 to solve for the x-intercept. So the x-intercepts are positive 7 and negative 1. So basically, the intercept form of this equation is just this one. Okay, x minus 7, because the value of a here is equal to 1. So that would be f of x equals 1 times x minus 7 times x plus 1. Now let's try another one. What if we're given f of x equals 3x squared minus 27? But we can rewrite this. We can factor out 3, and we'll be left with x squared minus 9. And x squared minus 9 is the difference of two squares, and we can write this as x plus 3 times x minus 3. So these are now the factors of this equation, and this is also the intercept form of the equation, because a here is equivalent to 3. We have 3 here, and the intercepts are negative 3 and positive 3. Now let's try another problem. Let's say we're given f of x equals x squared minus 4x, right? Then we can factor out x here. It will be x times x minus 4, and then we equate each of the equation or the factors to 0. Then we get x equals 0 and x equals positive 4. So these are now the x-intercepts, and we can now write our equation in its intercept form. So a is 1 times x minus 0 times x minus 4. So this is now its intercept form.